Hello, Internet. I've made a neural network just for fun and to learn about neural networks. It's not a useful neural network at all. Um, it's for the thing this neural network does is it calculates the distance from a given coordinate on a two-dimensional plane to the coordinate 0 0.5, 0 0.5, which you can obviously do with a calculator much more efficiently and much more accurately than a neural network. But this is to learn about how neural networks work. And I'm gonna I'm gonna paste the link to this neural network in the description of this YouTube video, and so you can just download it yourself. But I'm just gonna go through the code quickly here. So first we define how many neurons are going to be in each layer. So 2 in the first layer, 6 in the second layer, and 1 neuron in the output layer. Then we use ReLU. I don't know how to pronounce it, but it's an activation function that I should also mention that I'm not going to explain how neural networks work. If you want to learn that, you should watch 3 Blue, 1 Brown's videos on YouTube on neural networks. It's a 4-part series that's going to explain everything you need to know. But we use an activation function called ReLU, or a version of ReLU. And yeah, so those are the derivatives of the ReLU are here. So we define different arrays for the weights and biases in the neurons. And then we have, this is just a simple function for toggling the button that starts the training of the neural network. So you can play and pause the training. This function is for entering a coordinate. So here you enter the x coordinate here, the y coordinate here. If we train, this was a bad training. I'm gonna see if I can get a better training run. You gotta get lucky. I don't know why. You gotta get the right initializations. Oh, that was a bad one. Yeah, maybe this is not a good neural network if you have to try this many times. That's pretty good. That's good. All right. So now we have the neural network is trained. And I'm gonna explain how it trains. If you don't understand that, or I'm not gonna explain it. I'm just gonna go through it, and you can go through the code. And if you don't understand the code, you should watch 3 Blue, 1 Brown's video. You should also know Python, or know some basic Python. I don't know a lot of Python. I'm just a very beginner. I'm not very good at this. You enter the x coordinate here, the y coordinate here, and it's gonna paste it's gonna print the distance to the coordinates 0 0.5, 0 0.5. This is the real answer, and it's the neural network's guess. So it was very close, very close. And if we change the coordinates, we get the answer. The right answer was 0 0.5, and it guessed 0.489, which is also pretty close. So this function is just for entering the information here, the x-coordinate, the y-coordinate, and pasting the right answer and the neural network's guess. After that, we create the graphical user interface using tk-enter, which we imported here. So we have a window, a canvas inside the window. Then we have these entries. These are these two text fields. Then we have a toggle, which is this toggle that we control using this function. The enter button is here. Yeah. Alright, then we have this forward pass function. This just it starts by resetting the starts by resetting all the or the hidden layer and the output layer, as well as the derivatives of all biases and weights. It sets them all to 0, and then it goes through the, like, if you have 3 layers of neurons, that means you have 2 layers of parameters in between the neurons. So we have two passes inside the forward pass. This pass is from the input layer to the hidden layer. This is from the hidden layer to the output layer. And you can see that here that if the output from a neuron is less than 0, it will be divided by 100. So with the normal ReLU function, it would be set to 0, but in this neural network we divide it by 100 instead. Since I think it was like, I encountered some problem when too many neurons were 0. It sort of, the neural network seemed to get stuck without improving. Since the derivatives, like too many of the derivatives were 0, which means that the backpropagation stopped backpropagating, I guess. This should not make sense to you if you don't understand backpropagation. So, if you're confused, just watch 3 Blue 1 Brown's video on backpropagation, or all of his videos. Then you should understand what I'm saying. The backpropagation, yeah, so this was the forward pass. This is the backpropagation. It seems simpler since the code has fewer lines. I think this is harder to understand, but it uses the chain rule to calculate the derivative of the cost function with respect to the weights here and the biases here. Yeah, I should mention that now, I don't know, these derivatives of the ReLUs are not calculated here. Those are calculated here in the forward pass, but all the other derivatives are calculated in the backpropagation algorithm, I think. Then we have the update parameters function, which is very simple. The thing it does is it takes each parameter, or each array of parameters, and updates every item in every array, or it subtracts from every item in every array 0.005 times the derivative of the cost with respect to that item, as you can see here. This function generates codes, and you can see here that it generates a random x coordinate, or x value, from -1 to +2. Same goes for y coordinate, but this is a different random number, but it's a random number between or within the same interval. Then we append this code with the x, y values, and as well as the distance between that coordinate and the 0.5 coordinate. So it appends an array to codes that has 3 items, where the first 2 items are given as input to the neural network, and the last item is the right answer, which we compare to the neural network's answer. So yeah, I should say that if you want, here you can see that the right answer is only one number. It's only one item, but perhaps you want to have more than one item. Maybe you want the right answer to be or like you want every answer to be an array of three different or maybe 5 different numbers. Then you have to change this number to 5, as well as change how many items are in this codes array, this codes array. Yeah. And then lastly, we have a function that updates everything. It's called passTime. It starts by generating codes. Then it sets the cost, or it defines. It actually don't have a variable called cost. It defines a variable called cost, which has the value 0. And then while the length of codes, so codes is a lot of different items. Like every code is a piece of information that we can train the neural network on. But we have a lot of codes every time we run this. So while the length of codes is more than 0, we forward pass and we use backpropagation. We update parameters, and then we delete that code. Here it's the codes pop 0. It means that we delete the first item in codes. And then after codes contains nothing, we divide the cost by the batch size. Batch size is like how many codes we train on each time. So we train on 1,000 a time, since batch size is 1,000. That means since we add this value to cost for every time we train, like for every code, we need to calculate the average cost, we need to divide by batch size, and also divide by third layer count to calculate the average cost, since this cost, this value is added to cost for every neuron in third layer count, or for every third layer count, for every neuron in the last layer. Then we, after cost has been given a value, we, yeah, we should actually put this after this. I think this is better. After this has been updated, we create this cost label, which is this label, and we, well, I think actually this is better. And yeah, before then we had deleted the old one. So to update this label, we delete the old one and create a new one. And then after 1 millisecond, we pass time again. So this happens every millisecond with a 1,000 codes. 1,000 codes every millisecond. I think it's in practice slower since the computer cannot do calculations that quickly. But it's really fast nonetheless. And that is everything I wanted to show you. I didn't go into detail about how backpropagation, what each of these factors mean. But that's something that is in the 3 blue 1 brown video. So you can watch that if you want to learn about that. You should probably already understand this. If you care about coding a neural network, you should probably already understand what this means. But yeah. Thank you for watching. I don't know if anybody finds this useful. I don't really know why I made this. I think it was to reinforce my knowledge, but at the same time I didn't go into detail about backpropagation, so did this really reinforce my knowledge at all? I don't know. Maybe. But thank you for watching.